Welcome to EPG Pathshala. I am Dr. Radhika Mamidi from IIIT Hyderabad. I'll be talking about dialogue systems. It's a very important application in natural language processing. This is a part of the linguistics course that all of you will be taking. So this module talks about dialogue systems, and there are some topics related to dialogue system, like types of dialogue system, architecture, issues in building dialogue system, what are the dialogue modeling can be captured using human-human dialogue, and also an annotation schema we'll be looking at, that is called Dialog Act, DAMSL, Dialog Act representation. So in all, we'll be first looking at dialogue per se. So what is a dialogue? A dialogue could be an interaction between more than two parties. It can be a multi-party interaction, or mostly when we are talking about dialogue system, we are talking about two people. So dialogue could be between two people, dialogue could be between computer and a system, or dialogue can be between a computer and a computer. So let us look at some examples. What is the goal of a dialogue? For example, if you look at two people talking, say Ethan and Julie, what do they talk about? So they talk about politics, that is, the goal is to exchange ideas, or they can be talking about how to solve a problem. So goal is to try to solve a problem, which includes negotiation and other things. Or it could be a random chit chat, which is not goal oriented. So, but when it comes to natural language dialogue, today's world, we look at the social media has become a very important tool in using for communication systems. So for example, we have earlier we used to have landline, now we have mobile phone with many apps. We have chat, email, different modes of communication, which can be, the input could be speech or typed text, or a menu based, gesture based, and the output again could be speech, text, graphical display, or animated body. So basically natural language dialogue includes utterances, exchange of utterances, but the interaction should be coherent, not but in casual conversations it could be goalless. It can have more than one participant. So basically, for a coherent interaction, the speaker's intention and the hearer's inference become very important. Now all these things are taken into consideration while building a dialogue system. So in this module, we'll be looking at the challenges that one faces while building a dialogue system. When we are talking about in speaker's intention, for example, we have the same utterance, do you know the time? And depending on the context, the inferences can be different. The speaker should have the correct context to understand what the intention of the speaker was. For example, do you know the time? This is an utterance. In one context, it means the hearer wants to know the time actually. In another context, it could be that the hearer is telling that the other person should hurry up. So basically we are talking of two things, sentence meaning and speaker meaning, which may or may not match. Now for this proper understanding, where the hearer draws the correct inference from the user's utterance, two things become important. One, the contextual knowledge, and the other, world knowledge. Both of them should be shared between the speaker and hearer. So this will contribute towards proper interaction with coherent interaction. Now when we come to human-human communication, we talk about pragmatic competence. That is, the speaker should have a shared knowledge about each other, the background knowledge about each other, also about the situations. And also they should have knowledge about the social distance, social status between the speakers involved, the cultural knowledge such as politeness, and the linguistic knowledge, which could be implicit as well as explicit. Now, what is the challenge in building dialogue systems then? Challenge in dialogue systems are in computing dialogues, developing human-computer interactive systems based on human-human interactions. So before we go deeply into dialogue systems, let me just introduce the background. I hope all of you know about discourse analysis and pragmatics. Now, dialogue system becomes a part of computational pragmatics. So what is computational pragmatics? Computational pragmatics studies from an explicitly computational point of view how relations between linguistic phenomena and the context of use govern speakers' abilities to interpret and generate utterances in conversation. In other words, how to compute the relations in terms of explicit representations. Computational pragmatics deals with giving linguistic expressions how to compute the relevant contextual properties, or given a particular context, how to compute the relevant linguistic expression. So basically computational pragmatics is dealing with the relation between linguistic expressions and contextual information. Now, computational pragmatics is a very challenging field, and one of the applications of this field is dialogue systems. So as we had seen earlier, dialogue systems, they are able to interact with human users in natural language. They help us in making decisions on how to deal in a computational way with all phenomena related to language use. So what is a dialogue system? It is an artificial agent like robo or a computer system that can interact with human beings. It helps us understand the nature of dialogue and test theories. It helps us understanding the collaborative nature of interaction. It also helps us access information and services more efficiently. Now, dialogue systems, the first one that we had seen was Eliza. So Eliza is a simple Rogerian psychologist. It uses pattern matching to carry on limited form of conversation. It gives a general feeling that it is human, and it appears to have passed the Turing test. It is one of the first chatbot, and when it came out in 1960s, it was a very successful phenomenon with respect to artificial intelligence. What is the Turing test? Turing test involves three components: machine, human, and human judge. The judge asks questions of computer and human. Machine's job is to act like a human, and human's job is to convince judge that he is not the machine. The machine is judged intelligent if it can fool the judge. So the judge of intelligence is linked to appropriate answers to questions from the system. So Joseph Weizenbaum in 1966 developed this Eliza chatbot, but today we have many chatbots of advanced nature. If you look at this chatbot, my automated conversation coach, it's called MAN. It helps people overcome social phobia. Then today we have many more chatbots. You must have seen Siri, Cortana, Google Now, IBM Watson. All of them which help you find information about restaurants, hospitals, or shopping centers nearby, around you. All of them have this dialogue component in them. So what are the uses of dialogue systems? The phone-based dialogue systems help you get timetable information or flight booking information. Personal assistants like Siri or Cortana help you understand user needs and tasks. Then in education, it is used for intelligent tutoring. Then we have embodied conversational agents, which uses physical and facial gestures as well. Then we also have intelligent dialogue systems, which help us in smart homes or smart cars. They understand and behave according to the situations and activities. Coming to types of dialogue systems, the available types of dialogue systems are interactive voice systems, like the one we see in railway inquiry, where we accomplish the task by pressing certain numbers. Then question answering systems. Example, Start, a web-based QA system answering users' questions on movies, places, people, etc. Then we also have natural language interfaces, which are popular in tutoring systems or trip planning systems. Basically, dialogue systems can be categorized as task-oriented or restricted to a domain or a general domain, and the basic phenomena that one looks for in dialogue system is the one that is easier to implement. Ultimate goal to have dialogue systems is to have one that talks like human beings, displaying intelligence in understanding the complex cognitive structure of language. In simple words, dialogue systems have to be like humans, talking like humans, and thinking like humans, and responding like humans. So currently, dialogue domains are in travel, transport, business, car navigation, health-related inquiries, or just any online information access. We can divide dialogue systems as two types: single initiative system and mixed initiative system. In single initiative system, one of them, say human or a system, guide the user through a series of scripted prompts. So here the system is basically asking questions and the user is providing answers. In mixed initiative system, both the system and human have equal role of turn taking, so they are cooperative and the responses are flexible according to the user's queries. Example, the available systems that talk about restaurants or weather domains. So this is a simple architecture of a dialogue system, of actually a spoken dialogue system. So we have automated speech recognition system, then dialogue manager, language understanding module, language generator module, then domain manager, and finally text-to-speech module. So basically the user utterance is converted into text and then it is sent to the language understanding module where the basic language analysis is done. Then once the idea is comprehended, then some information is taken from domain manager and then the response is again generated using language generator tools, and the output is in a natural language form, which is converted into speech using the TTS tool. So the input is in speech form and the output is also speech form. Now this can be just plugged in, but otherwise we have text-to-text dialogue systems also. So the basic tasks of a dialogue manager would be to maintain and update context, decide what to do next, and it also provides a good interface for backend or for tasks. It also provides expectations for interpretation. Now in this module, we will be focusing on language understanding. Now language understanding, because the input is in language, natural language, it needs basic parsing. So the speech or at the word level, we are assuming all the parsers are done, and then at the pragmatic level, it becomes important to capture the intention of the user. And spoken language may also have other things like intonation that also has to be captured. So every speech act is associated with a single utterance that has to be captured by the language understanding module. Then after capturing the intention, it becomes important to identifying it with the task associated. Now there are other things that happens within language understanding module, like anaphora resolution or ellipsis, grounding, clarification. All of them are utilized so that the output sounds very natural, as if it's a human being giving the response. Now, though the natural language understanding module looks pretty with all the components intact, still the dialogue systems become a challenge in being formulated. And why? Because we want natural language systems, natural language dialogue systems to be as natural like a human being. Now, why it becomes difficult then? Because human language is complex and ambiguous. We speak utterances without meaning what they may say. Like, for example, the speaker may have a negative answer in mind, but the sentence may be positive. So most of the times we answer things indirectly. Now, language understanding needs contextual and general knowledge apart from linguistic knowledge. So basically, the speaker and hearer should have shared knowledge, and now all this representation computationally becomes a challenge. So here are some examples which shows human language is complex and ambiguous. For example, when shorted, the dove into the bushes. Now, if you look at the spellings DOVE, both of them look the same, but one is a noun and the other is a verb, and the pronunciation changes according to the context. But in the next example, again the part of speech are different for invalid. The insurance was invalid for the invalid. So here you see that the part of speech of both are different and the pronunciation is the same. The meanings are different. Similarly, you have other words like DOES. The buck does funny things when the doors are present. Or upon seeing the tear in the painting, I shed a tear. So all of these show that according to the context, the pronunciation is changing, the part of speech is changing, all the meanings are changing. Now these things, the ambiguity is very easy for a human being to parse. When it comes to a system, the system should handle these things, and the related modules should be efficient in doing this, because the output of one system becomes input of the other. So if there is an error in the output, in the analysis part, the mistake gets carried forward. Now this is a model of language processing, where you see that lexical processing, syntactic processing, semantic processing, discourse processing, all of them takes simultaneously. They are not in a linear order, but the processing happens simultaneously, and it also takes in information from our memory. So that cloud is our brain, where the memory stores the lexicon, syntactic rules, semantic rules, and discourse rules. Now this kind of language processing model is needed in building computational models. So let us look at a dialogue model. So these are the two important approaches, pattern-based approach and plan-based approach, and all of them use some kind of linguistic knowledge as well as artificial intelligence in building dialogue systems. This is the framework given by James Allen, which uses techniques that are very simple to the most complex ones. So finite state script, frame-based, sets of contexts, plan-based, and agent-based. So if you look at this, all of them have different different users depending on the task they are being employed. Finite state script is the easiest one. The user answers questions, whereas in frame-based, again user asks questions, and the system also has a clarification module, and there is some interaction between system and user for the task completion. Then sets of contexts is where the shift between predetermined topics take place. And plan-based models, there is a certain kind of negotiation that happens between the speaker and the hearer. Agent-based task is more complicated. It works according to the different modalities in the real world. And according to James Allen, these are the intelligent agent components. That is, intelligent dialogue system should have these components if it wants to be like a human being. Perception, beliefs, desires, planning, commitment, intentions, and acting to accomplish a given task. Now, for all these things, because we want dialogue systems to be like human conversational agent, so we see that it needs data, and for this purpose, data is collected in the form of conversations between two humans, or it is collected using Wizard of Oz system, where one of the human beings pretend to be a computer, or it can also be conversations between the chatbot, human and a system. Now for this, there is an annotation schema which is used based on speech acts. Searle speech acts are assertives, directives, commissives, expressives, declarations. Based on this DAMSL annotation schema was developed. DAMSL is nothing but dialogue act markup in several layers. It has 4 components. Communicative status, where it talks about the utterance, whether it is clear, whether the utterance is meaningful, whether the utterance is fulfilled or full utterance. Then the content within the utterance is at the information level. And then there are 2 functions that are marked, forward-looking function and backward-looking function, where the context is taken into consideration. This is an example conversation which has taggings according to the DAMSL annotation schema. I think we should meet soon is a suggestion. Yeah, agreement. How about tomorrow? A suggestion. Tomorrow I'm busy. Indirectly, the person is saying that it is a negation to the suggestion given. And then the negotiation begins. So at each stage, each utterance is given a dialogue act, and this dialogue act helps in building better dialogue systems. So this is a sample of dialogue act schema. Now, challenges in building dialogue systems come at every stage, as we had seen, at word level, sentence level, or discourse level. Now, even at the basic thing that we had started this talk of recognizing intention and making proper inference. So we have an example here. It is cloudy is an utterance. Now at each stage, and depending on the context, the dialogue act may be different. Lend me your umbrella, it is cloudy. Here it is cloudy means a request. Don't water the plants now, it is cloudy. So the utterance is a warning. It will rain today, it is cloudy, an assertion. So similarly, if you look at inferences, the speaker says something which may not be derived from the actual meaning of the sentence. So now the hearer should have full contextual information or the shared contextual information to draw the proper inference. So as we have seen, dialogue system becomes a very important part of our everyday life. Now with all existing applications like Siri, Cortana or IBM Watson, we see that they have become a very important part and they are very handy. They are part of your mobile phone, which is like next to your skin, which you carry all the time. So here in NLP, dialogue system has become a very important thing, and to build dialogue system, we take in inputs from linguistics, and from linguistics, basically pragmatics form the basis of computational pragmatics, and dialogue allows to explore novel challenges in building language technologies. So as we have seen that human-human dialogue helps in building this computer user dialogue systems. So but we have to be very careful because in human-human dialogue there are lots of errors, but we don't want them to be incorporated in human-system dialogue. Similarly, the goal of a dialogue system is to be very dynamic, mixed initiative, multi-domain and multi-party interactions. We don't want it to be a single initiative system where the computer just directs the user to press certain buttons. We want the system to be more interactive. So the challenges are in handling pragmatic and discourse related issues, like we had seen in recognizing intention or drawing inferences. Apart from that, there are other linguistic issues like anaphora resolution, ellipsis handling, then also trying to understand the utterances of the user and responding accordingly. And most of the dialogue systems today are in English. We want to have dialogue systems in Indian languages as well. So for this, the Indian linguistics has to be studied very well, and hopefully one day we will have dialogue systems as many as we have languages in India. Thank you.